I'm Arvind Venkatesan. I work as a data scientist with the Literature Service Group at the European Bioinformatics Institute. Firstly, I would like to thank the organizers for giving me an opportunity to present our work here. Today, I will be presenting a tool that deals with linking literature and the underlying data using text-mined annotations. Before I proceed with the details of the tool, I would like to give an overview of what we do at the EBI. So essentially, our group works on building open full-text scientific literature resources and to support innovation by engaging with users and enabling contributors and integrating related research data. An outcome of this is the Europe Pubmed Central Literature Database, formerly known as UK PMC. So Europe PMC essentially has over 30 million documents, out of which 3.5 million full-text articles, and also over 29 million PubMed abstracts. The data in Europe PMC can be searched by citations, named entities, data links, and also by section-level searches. And the data can also be accessed programmatically and also available as bulk data. Having said that, Europe PMC is not just a database, it's more of an interactive platform. We use text mining approaches to make links between data and the literature, be it bioentities like genes, proteins, ontological concepts, organisms, and so forth. Additionally, we also have a advanced search tool where users could search according to citations, license types, and also external links. So these features are useful, but it's not enough. Basically, because we are in the age of big data, and life science is no exception to it. So what we have to do is make literature more accessible to users, mainly curators. So what curators do is they have to go through every paper and make the corresponding information into the, they need to upload the corresponding information to the respective databases. This is firstly time consuming, and it's very cumbersome. And so essentially, this is why we need annotations. And so what we have opted for is a open infrastructure where Europe PMC is, we use text mining as a main method to extract the entities, and also we are also open to collaborating with other text mining groups to provide their annotations. By this way, we could build applications on top of the platform and also engage with users in order to serve them best. So, so as I said, this slide just sums up what essentially I spoke about. So we want to extract the essence of scientific articles and help manual curation scale to the big data needs. And also there is a need to integrate the underlying data with the respective databases to make more deep queries and to aid in hypothesis generation. So recently on this line, we have developed Scilite, a web annotation tool that essentially extends the current text mining modules to make deeper links. And also this time we want to make it more, make the annotations machine interoperable by opting for the linked data technologies. We follow the web annotation data model to share our annotations, and we also engage with other text mining groups to include a variety of annotation types. For instance, functional annotations and biological events and so on. So this is the annotation pipeline. What we do is we take all full text articles that are of CC BY license, and we apply we text mine these articles, and we use section tagging and other methods to basically semantically tag these articles, and then these annotations are exposed as RDF, and they are stored in a dedicated RDF triple store, and also we include the external annotations. Generally, we encourage providers to sort of follow the web annotation model. We also provide some sort of assistance in modeling the data. So this is an example of this is the example of the data model we have used. All text mine annotations that we have mined are of the text code selector. So you have a postfix, prefix, and the annotation. And to the right, there is an example of an external annotation modeled as a fragment selector. So additionally, what Scilite brings to the table is deeper integration, because at the EPI we have an RDF platform where we may basically develop to link all the major EBI databases and make it more interoperable. So the Scilite RDF store is part of it, and this helps the power users to launch complex Sparkle queries, and also the annotation adds an extra provenance layer to the queries. And so what we have done at the inception, we were clear that we didn't want to have a technology push, and it should be more of a user-driven development. So we regularly engage with curators and researchers to understand what their needs are and how the annotations need to be represented on the web page. This has to do with both how it appears, because some curators felt that it was distracting for them if the annotations were on all the time. So we had to sort of improve our pipeline and the modules to make it on demand. And also that, so we also used this usability testing to improve our dictionaries, text mining dictionaries, and also add extra provenance. So this is an example of the annotations displayed on the EU PMC website. So you're seeing a full text articles where the annotations are fetched on demand. That is, a user, when he is viewing a particular paper, there are Sparkle requests to fetch all annotations for that particular article. In this example, you see that there is a combination of text mine annotations provided by us and a collaborator. So what this helps is we are able to overlay different text mine annotations and provide more provenance in terms of where it's coming from, where the link would lead to. Additionally, this is another example of text mine annotations coming from NACTM and overlaid with our output. So here, for instance, you have a biological event, phosphorylation, and the protein that is getting phosphorylated, that's the HO1. So additionally, what we have done is we have used the pop-up to deploy additional applications on top of it to make it more interactive and more useful for the curators. So for instance here, when here there is an accession number being annotated, and for that particular ID, we fetch in this case it's a protein structure. So we fetch the protein structure so that the users could play around with it, and it's interactive, so it's a 3D structure where people could understand better what the structure is all about. And so the idea is to develop more applications on top of this framework. Additionally, there is a feedback system where which will help us improve the annotations. So if it's good annotation, that's great. But more interestingly, we would like to know what's wrong with the annotation, if at all. So in this case, if they report, we will be able to gather information of whether it is an incorrect annotation or it is it's too generic and so on and so forth. And we also get some comments as to if a particular annotation is wrong and it's throughout the article, then the user could help us fix that. As we developed, we came across some challenges. So mainly, we are dealing with, since we are a cross-platform resource, we are dealing with different user bases, so there are different needs. Some users don't want to, they are not interested in gene functions. Some are more interested in organisms. So this is something that we need to deal with. And also, we need to continuously work on refining the quality of text mining and reduce false positives as much as possible. And since this is a sort of a real-time fetching infrastructure, we deal with a lot of performance issues depending on the number of annotations a particular article has. So these are some of the challenges that we are working on. So for the future, firstly, we will be releasing, we will be going live by the end of June. And additionally, we are also planning to have include more annotations from external contributors. And the other aspect is to make annotations customizable. So this is to deal with the heterogeneity of the user base. So we would like to facilitate the users with choosing which annotation they want, and they could probably log in and choose a particular annotation type, and then and for their account, only those annotations will be displayed. And additionally, we would like to use, as I mentioned, the pop-up to make more useful information available for the users. So, so with Sci-Lite, we have sort of made the initial steps to bring the literature data close to the underlying data. And we would like to make this more of a collaborative effort where the curators take active part in the annotations and in terms of sharing the annotations. And also we would like to engage with other groups, not essentially not from the curation community. We would like to work with application developers to build useful tools and apps for on top of the current infrastructure, and also text miners and readers to give more input to make this a sort of a more of a success, where there is more collaboration and there is a two-way system. So finally, I would like to thank all the contributors for Sci-Lite, and thank you.
We have time for some questions. John? So first of all, this looks like a beautiful thing. Congratulations and thank you. To spin back to the slide, or you don't have to spin the slide, but you talked about using text quote selectors for text mine annotations, and then you said fragment selectors for external. Can you just expand on that a bit?
So this has to do with the type of annotations. So the text code selector is essentially for a specific entity.
Yep.
So we can use a postfix and a prefix. For a fragment selector, in this case, it's a statement that a curator is making. So that itself is the entire fragment is of importance to us. Hence, we chose for a fragment selector.
Okay, thank you.
Any other questions for Arvind?
Since you mentioned you've been doing a bunch of usability research, are the results of that written up as a report, or is any of the outputs of that available anywhere for other people implementing annotation tools?
We do record the sessions both in text and audio, but we have not yet made it available for the public.